I'm going to take some votes today. Today I want to talk about some specific weirdo number systems. Put that down. We don't need the calculators should all go off right now and not be played with because we're not talking about them right now. When we need them, we'll bring them out. Right now I'm going to talk about some things that we might discuss, and I want you to choose which ones you want to talk about first and second and third. So I'm going to talk about weirdo number systems, okay? Because some people amongst us want to invent weirdo number systems. Weirdo is the technical term. I just mean a little different, like different from the real number system. Yeah?
Wait, that's actually... Can we invent a number system where we can origami with numbers? A what? Hello?
Actually, there is an axiomatic system for origami. So I'll put axioms of origami.
Okay.
It is a thing. So origami. We also have braids. Braids
Do we have chocolate
can
pie?
do arithmetic.
Chocolate pie.
We have, wait, keep your hands down. We also have transformations. This means moving shapes around so that they land back on themselves. This is related to symmetry. Okay. We also have complex numbers, so reals and imaginaries. We also have modular arithmetic. This is number systems that go in circles. Number loops instead of number lines.
Like clocks, which go from 1 to 12 and
Got it.
then go around.
Okay. So here are some other options.
12 p.m. is actually.
We also have something called matrices. And matrices are cool because matrix algebra, it's possible to have the complex numbers with the hallucinatory numbers with the real numbers all at the same time. That's all exciting. Yes?
What about bananas? Axioms?
I don't think I have those, but we'll write it down and you'll have to tell me what they are.
Okay, that you could make a banana split out of...
I don't already
add
have an
banana
axiomatic
split.
system. I don't already have an axiomatic system for banana splits, but maybe you guys can come up with one.
Yeah,
Banana split.
Ooh, you could add
I bet you guys could actually create such a thing.
ice cream.
But we
okay,
would
you could make banana splits
Ice
out
cream
of number
to figure out
system.
how many banana splits that would make.
Okay, so these are all different things we could do. There are more, of course,
And three.
but I'd like for people to vote. If you are interested, you're allowed to vote as many times as you want, but if it is interesting to you, if you're like, I wonder what that would be, I want you to raise your hand.
Every single one.
So when I say axioms of origami, does everyone know what paper folding is? Origami? Yeah.
Like this?
So vote for it. How many people would be interested in seeing the axioms of origami? Okay, we have 2. Oh, we've got 4.
No, that's 3.5.
Is that 3.5?
vote, yeah.
3.5 people are interested in that. How about braids? Axioms of braids. 1, 2, 3, 4. Is that a full 5? Okay.
Braiding
Okay.
my hair.
Transformations.
Is that for girls?
Yes, I do mean braids. 1,
like
2, 3. Transformations. It's like moving shapes
He
around.
needs his hair. It's the
Okay.
longest.
Complex numbers. So this is reals and imaginary numbers and like understanding how they work. 1, 2, 3, 4.
Imaginary numbers.
Is that a half or a full?
Yeah,
Oh, okay.
1.75.
1, 2, 3, 4, 5, 6. 6 people are
That's
I have-
5.75.
I have
5.75.
6. I have
Vote
6.
for that one.
I have 6.
Okay, right? Put your hands down. We're voting. Okay. Modular arithmetics. Those are number loopy things. Instead of number lines. 1, 2.
1/2.
Is that a half?
It's 1/2.
A 1, a 2, a half, and what are you? What fraction are you?
8, 4, 6, 8, 9, 10.
How about we stick with a half? That's the only fraction available.
How about 0.75?
What's this then? This
Hey,
is
I'm
0.
gonna vote 4 times.
I think I'll put 3 point.
All we have to put up is
Four
our phalanges. So I 20 phalanges.
3.
Watch.
I'm going to the nearest 10.
15.
Okay.
9, 8, 4, 6, 9.
Matrices. This is where we can see not only
Banana
different kinds
splits.
of arithmetic, but you can do complex numbers, you can do real numbers, you can do hallucinatory, you can do all kinds of stuff.
Wait, what?
With matrices. Vote for matrices.
Wait, what?
What is that?
Votes.
That's four.
Votes.
That's four and
What's that?
that's two.
I don't think that
That's two
you're,
and
I don't think you're allowed to vote as one person. I don't think your vote can exceed one.
What?
So is that a full one then? Okay.
yeah. This is two and two more rough.
Wait, if we cut,
You're excited about that one. 1, 2,
wait, what if we cut
Three.
ourselves in half?
4. Is that the full one?
Grow new arms.
That's more than one.
And I chop
5.
off each of my fingers and have them, but.
No, I'll chop
6.
little lines
6.
in them. Got tiny hands. I'll chop little lines in them. I got tiny hands.
Oh, no, we can separate all
How
our
many
fingers.
people? Whoa! How many are interested in inventing a banana split?
Go right here.
Shaky, shaky. Okay. Well, that one is pretty popular, but
Let me push this button that will make the world explode.
here's what I'm going to do.
Good idea.
In the interest of, wait, no, wait, what? You want to have fee votes?
That's a bit complicated.
It's more than one, so it's already a problem. It was at 1.6.
Square root of 5 plus 1
Something
divided by 2.
That's it. Square root of, yep. It's that number. Fee. Okay, let's, what I'm going to do is we're going to start with the complex ones. Even though there are slightly more votes for matrices, these are sort of in there. So I want us to look at these first, and then before we make it four-dimensional. Because this is two-dimensional number system. This is a four-dimensional number system. And it could be worse if we let the matrices grow.
Oh no!
So,
no matrices.
Let's start with one dimension more complicated than usual. Yes?
He's standing now. You better answer his question.
Is that the rule?
A number system
He's
with
standing here. You better answer his question.
dimensions.
I dimensions.
I dimensions?
No, it's going to be a two-dimensional
I
number system.
dimensions.
With a
I
complex
dimensions.
number of
Oh,
dimensions.
imaginary.
With a complex number of dimensions.
You're gonna die.
We'll have to come back to that question.
With a folded number of dimensions.
We're going to do the regular complex numbers which have two dimensions. So, all right, I guess I'm going to write these smaller. We had a complex number systems first, and then we had matrices,
And we had banana splits.
and then banana splits and braids are right there. So banana, splits,
You're seeing down.
braids, then I think it would be origami, modular arithmetics.
What?
And then transformations. That was the order. That's pretty messy writing, but we'll go with it. Okay. So, complex numbers.
Okay.
Yep. So the thing about the complex numbers is it starts with the real numbers, right? Here they are, the real number line. 0, 1, 2, 3. And what kinds of things can we do with real numbers?
Ooh, we can play with
Add them.
We can add them, we can.
Play with them.
What else besides adding them? What other operations?
Subtract,
Multiply, divide.
Subtract.
We could also take
Exponentiate.
exponentiate and take square roots as long as we're not taking square roots of negatives, right? So those are all legal things to do with real numbers. So what happened was, someday when someone was like, oh, I would really like to be able to take square roots of the negative ones too. And so they had to invent new numbers that would allow that to happen. Those numbers don't live on the real number line, so they had to pick another dimension to put those numbers in. Wait a second. So here is the real number line.
You have to wait.
And they actually, because this number line couldn't hold this idea of the square root of -1, which they really wanted to play with, they created another dimension, a second dimension, right? Off the line is one dimension. A plane has two dimensions. So there's room in this plan for I, which is the square root.
portals?
Yeah, we just made another dimension. And here it is, 2i, 3i, -I, -2i. negative 3i, negative 4i. It looks like that.
Go to
Yes.
sleep.
Yes. You have a question?
If we knock a complex number off its number plane, would it go onto the number line and touch it, or would the number line start going attached to it?
That's a really good question, but I think it actually doesn't fall. It's flat plane.
What if we knocked it down? Or what if we picked it up and threw it?
Well, actually, we can knock it down, and we can also pick it up and throw it, but we have to be precise about what that means.
Could we throw it at the number line?
Wait.
How can you throw something at the number line?
Okay.
They
So
can do
here
that in
is the real number line. Here's the imaginary number line, and we have these objects that are now called complex numbers. And complex numbers have a real part and an imaginary part. And the idea is, so they might look something like, for example, 4 plus 5i, or negative 2 plus a negative 3i, also known to its friends as negative 2 minus 3i, since adding a negative should be defined as subtraction, or subtraction should be defined as adding a negative, I should say. Now here's the thing, we have axioms for the real number line, right? We have rules for how we add, subtract, multiply, divide, all kinds of stuff. Those rules should still work. That's our hope, right? We don't want to destroy the real number line just because we put more onto it. So we'd like that to still stay the same as it's ever been. But now we want to be able to add things like this, or subtract them, or multiply them, or divide them, or do all those things that we used to be able to do with real numbers. We want to be able to do them with complex numbers. Asian.
Can numbers hurt you?
Depends. It could hurt your head.
I don't know. Yeah? I think we're safe, but
If we rip 0 off the middle of the number line, then all the number lines collapse onto it, or would they all fly off and find a different 0?
you mean what if 0 wasn't there?
Yeah.
Yeah, it wouldn't make a very good number system without 0. Because remember, our axioms required an additive identity element of 0. So without 0, I don't know, we would be in trouble.
Then let's just make that the additive identity element of 1.
Well, that's a multiplicative identity element already. Yeah.
If 0 without a 0, that would destroy 10 and 20 because they all have zeros.
It would destroy a lot.
Let's push this button. Whoa, good idea.
So let's go ahead and look at adding these critters. So
Critters? What are critters?
complex numbers.
Oh.
It's the technical term for complex. No, it's not. Okay, so how do we add complex numbers? Now, the axiom says this. A plus bi plus c plus di is a plus c plus b plus d I. What does it mean? How do I add
47.
4 plus 5i plus negative 2 plus negative 3i? What will be the answer to that? How do we do it? Yeah? You know, are you answering my question? Then save it.
First we add the
Save
real
it.
numbers, then we add the imaginary numbers.
So first we add the real numbers, that's what this axiom says, right? It says first add the real parts, then add the imaginary parts. Okay, so what is 4 plus a negative 2?
4 plus a negative 2.
Yes, what's 4 plus a negative 2?
2.
2.
2. And what is 5 plus a negative 3?
Hold on.
2.
2.
Yeah. So it's 2 plus 2i. Is the answer.
Yeah. So basically it applies the same way, you just add an I if there's 2.
Yeah, but you don't add the real part to the imaginary part, right? It doesn't make sense to combine real numbers with imaginary numbers. It doesn't work like
Because you're
that.
not combining like terms.
Yeah, exactly. That's exactly the right idea. Yeah. So, there we go. Now, there is also something that's really cool about this. And this is a geometric interpretation. So let me see if I have.
I like it. I know, but you're not a geometry person.
And with Ed. So
Put that away.
Everyone is going to need a piece of graph paper. Oh, we have more there too. It doesn't matter if you use that size or this size.
And then,
Oh, it is.
Can help him out then. There you
I
go.
get it.
how can I get that?
Design way. Go, catch the
Oh, don't worry about it. This table is very old.
Can I get it off?
Don't worry about it.
Did
Okay.
I have a pencil for this?
Oh yeah, pencils.
Alright, that.
Pencils are in this box.
I lost my paper. Okay.
So does everyone have a piece of graph paper and a piece
What
of
is that thing?
that?
What? Moving thing. No! Well, it hurt me.
What is this?
It will be all right.
I don't see anything.
It's probably toxic or no, not toxic. Poisonous.
Okay,
Yeah,
we're going
we
to.
gonna be graphing?
We are going to be graphing.
Nothing.
So right in the middle, right in the middle of your paper, right in the middle of your paper, make axes.
Ooh, yay.
And what I want you to put on there is there should be a 0 in the middle, and then it should go 1, 2, 3, 4, and then this way -1, -2, -3, -4. And this way it should go I, 2I, 3I, and down here -I, -2I, -3I, -4I, like that.
Wait, does it have to be exactly in the middle of the paper?
No.
Can I
No.
have to put
More
5
like
on
one
this
straight line.
somewhere?
Um,
No, like diagonal?
well, the way that this is where phi would live. It goes right there, but it doesn't. It's not an integer.
So can I put
Lines like stretch.
You can make it little,
Can I put like a dot and trophy?
like that.
Like this.
Right, on your paper. So make sure you get the integers, because the integers are sort of good landmarks for where am I now?
Alright. Imaginary numbers.
-5.
In the middle.
My question is,
No,
how
it's
can
just
you
a-
imaginary if they're on their own number line? It's very confusing.
Yeah, well,
How come we
imaginary
find
might not be the
real
best
numbers?
word for them. Imaginary is just a word we made up, but what's interesting is that physics actually uses imaginary numbers to do things that are real. They use
I don't like physics though.
real and imaginary numbers to describe the components of light, the electromagnetic part and the magnetic part. So there are actually uses for them. But the thing about math is, it's a lot of people wonder. It's pretty crazy that if you add 4 dogs to 2 dogs,
That
it's 6
equals
dogs.
dog.
But if you add 4 pencils to 2 pencils,
That's
guess what?
It's 6 pencils.
It's 6 pencils. What is up with that?
That's
Like,
8 plus
how
2.
is it that if you add dogs or you add pencils, the theory works the same way? That's crazy, right?
Because a crazy guy created mathematics.
It's
And he just went
crazy
and
that
made
just
hard
works.
to understand.
So that's called the unreasonable effectiveness of mathematics. Like, it wouldn't make sense that math should just actually work out to be useful, but
Apparently it does.
funny enough, it is. Mathematics is really a language for describing patterns that always work the same way. And when you're talking about the underlying patterns, it turns out that anything that kind of works like that, works like that.
My timeline's horrible. Can I draw on the back?
Yes, yes.
I need a timeline. Can you help me with
It shouldn't be a
that?
timeline, it should be a
Timeline?
complex plane.
Okay,
Yeah, we're doing a complex
Yeah,
plane.
but how can I measure these precisely?
There are lines on the paper, and every line should be a 1.
They don't answer his question.
Then you
Yes.
made animals.
What's your question? Are you drawing your lines not using the lines on the paper? Yes. So the reason, okay, so let me explain this.
Hey.
Actually, can I get, we have a couple younger members of the audience. Josh, can you hold up your paper for a second? Now, Reza,
He did it very neatly.
look at how he used the lines on his paper to actually put the marks evenly spaced. You see? He actually drew the lines along the blue lines, not across them. So make sure you do that. Also, I have to pick on you for one thing though.
Okay.
How far is it from 0 to 1?
That's
One.
2 spots right there.
Oh. I made my 0 bigger.
Just like.
Yes, but is 0 bigger?
No, wait, 0 is bigger
0
than
is the
negative 1.
center of the number.
So adjust that a little bit. You got your lines well lined up.
It's the center of the universe.
And move it to the 1.
Yeah.
Who created mathematics?
Who created mathematics?
I think it was
People.
a bunch of
It was everyone
No,
at the same time.
People all over the world have always created mathematics.
So what did it start out as?
What did it start out as?
probably guys drawing sticks or something.
Well, why do you think
Counting
people?
sticks.
Why do you think people even came up with numbers at all in the first place? Like,
So they can count how much food they had.
sure, like
So
how
they don't get.
or trading.
Figuring out if animals are stealing the stuff.
Yes, keeping track of things.
So
Yeah,
they could count how many organs they had in their body.
yeah.
So they can keep
count
track
the number of
on.
enemies they have killed.
So they can keep track on how many bugs there are.
To keep track of how many
Yep.
people they
Math is useful for
So they
describing
can
all
count
kinds of
how many
patterns. And
bugs
it's not
fly in
just
their
numbers; it's also shapes, right? Like, shapes are also a kind of pattern. I'm waiting.
to keep track of how
My thumb's getting kind of sore.
Oh
So,
no!
shapes-
I would just fall out.
Shapes are also useful for describing how things are in the world. Is there such a thing in the real
Wait,
world?
so you mean they can tell you about the world?
Sort
Number
of.
one,
Is there such a thing?
two.
Is there such a thing as a perfect circle? Like a really perfect circle in the real world?
Yeah.
Yes.
No, not
Wait, in the real
No.
world?
In
No.
the
Are we
real
not in the
world,
real
is there such a thing as a perfect circle?
Yeah, my head.
We're not in the real world?
What?
She just
there are always little
My
atoms
eyeballs.
that make it not a
Well, atoms aren't
Right, the
circular.
little atoms, and they kind of wobble too. It's
Atoms aren't circular.
are not perfect circles.
Oh, I think it's
Atoms.
atoms.
Yeah, atoms.
And
I think it's atoms.
That eye on his shirt. That's an Egyptian tiny classic.
That's
It's
true.
Horus, the eye of Horus.
But I have a question for you,
It's
Guys.
a beetle.
No, it's not. It's the eye of Horus.
but guys,
There is a beetle of rock.
but guys, even though there's not such a thing as a perfect circle in the world, does that mean that circles are useless to ever think about? Like, are circles useful?
Sometimes.
Is the idea of a circle useful, even though there's no such thing as a perfect circle in the world?
I really don't use it.
No, that's Yeah.
Now let me ask you about this. How about the number 1? Is there such a thing as the number 1?
Well,
In the real world.
No. Oh yeah, number one teddy bear.
In the real world, is there such a thing as the number 1?
Yes.
No.
Oh.
Those little foam hand things. They go like this. They're foam hand things.
Do numbers really exist?
Yes.
I don't know.
I don't know. You're using me.
It's
Stop
philosophy.
it.
This is philosophy.
My
That's
head.
exactly right.
Philosophy.
That's exactly right.
Thank God for my dad.
No more. No more. No more.
Okay?
It's philosophy. No more. No
really
more.
hard.
It's my head.
It's really hard. It's philosophy.
No,
We should go this way now. That's enough numbers this
My
way.
head hurts.
So
I
now
know
go,
it's gonna explode.
yes, and then go to
There are way
-1
harder
and
questions.
-2. But we're probably going to
One
So,
problem too.
after you get your
Wait.
after you get your complex plane drawn, I do want you to plot 2 numbers. One of them is going to one of them is going to be 4 plus 2i,
14.
4 plus 2i. Got
and
it.
the other one.
Wait, I'm still making my
Wait,
thingy.
I am too. I'm still making
That's
my
okay.
I'm still making my thingy too,
And I want you
and
to
I got
put
way.
I want you to put a dot there and call it A.
Okay.
Wait, we're not
And then
This dot is called A.
just for the fun of it, what should our next dot be called?
B.
No. Z.
Z. Why not?
Yay!
How about we call it
No, it's really-
Quartuple?
So
Z, why
then-
not?
Negative. This one I want you to put at -2
Hey, there's already a negative inside you.
plus. Oh, by the way, my handwriting is a little bit messy, and a lot of mathematicians want to make sure that they don't confuse their Z's with their 2's. So a lot of mathematicians adopt the
and
habit
British
of putting
people.
a bar across the middle of their Z
British people.
for that reason. And I do that just to make sure that my handwriting doesn't get confused.
And British people.
And British people. -2 plus see, 3i. So I want you to plot point A
Oh, are we gonna do another?
and point Z on the complex plane after you've got your complex plane drawn.
Okay.
Okay. Try to put the dot where it goes and put the letter next to it. The dot. Yes.
If we do another one, can we do the
I did it.
Can we do what?
The omega symbol.
Oh, well, we'll keep that in
Dude,
mind.
that's a letter.
Yeah, he wants the omega for the next label.
Oh.
I know, it's a Greek letter.
It's perfectly legit. We can use Greek letters. Why not?
Yeah.
I memorized names of
But we should also use the alpha.
Yeah.
How am I gonna make a line here without showing
What?
the zero?
That's a tragedy. You'll just have to do it. The zero will be a casualty. Because it has to be the right
Bye,
number.
zero.
We're in the
Kill
alpha.
me.
I'm done.
Look, it happened to mine too.
Yeah, you
Start.
I killed my zero also. I just ran right over it.
We will also.
It's a casualty.
together.
Sometimes people put their zeros right on the center. I think that actually Josh did it that way. It was a good idea. He put the zero right on the middle, so
Oh,
it
that's
was
what I did.
equally squashed by everything.
Mine's not exactly very equal.
Or cut up by
It's kind of off center.
Yeah, if you want to put
Oh,
it.
it's
I
1
finished
4 plus
doing
1
the
4 plus
marking.
1 4.
You got them?
Yeah.
Okay. Now, here's the next thing. We are going to think like a physicist right now. Physicists love vectors.
What are
Vectors
Vectors are
are
awesome.
arrows. They are lines with an arrow at the end. And what I want you to do is I want you to start at the
I'm gonna
center
get done with this. Can you
and draw a line to A and put an arrow pointing in that direction.
So I'm gonna run over my number.
Yeah, go ahead.
11?
Run right over it.
I. 20.
I.
13. I. Plus 2.
Someone shoot.
Okay?
Wait, but I thought
Do
you
the
said
same thing for Z. Put a vector going from the center to Z.
But I thought you
Let's
said
think.
There we
The
go.
dangerous pass.
add
I did it.
plus imaginary numbers.
I did it.
We're able to. And
We can't add real numbers and imaginary numbers, but we can add complex numbers with complex numbers.
that's confusing.
I know. So put a line that draws an arrow from 0 to A and from 0 to Z after you get these
I
plotted.
did it.
Oh,
I'm having trouble.
And now I want you to work out what is, if we called this A, and I'm actually going to put an equal sign here.
15I.
This is A,
16I.
and this is Z.
17I.
What I want to know is what is A plus Z,
19I.
and where does it live? And put that on your,
Ooh, we can use
Complex
the omega
plane.
symbol for that one.
also put a dot for that one.
I'm having trouble. 18.
Oh, that.
What's your trouble?
19I.
So remember, how do we add
I.
complex numbers together?
Could you
Wait,
tell
where's
us
the
again?
symbol?
I don't think I was listening. I think I was trying to.
So this is negative 1i, negative 2i, negative 3i, negative 4i.
I have a question.
Yeah.
You know, here on negative,
That's why I
negative
cannot pay attention.
y, do I put it over here or
It's down here. It's right on the line.
no, it's supposed to be here?
Well, where you're writing is there, but the dot, negative I, lives right on that line.
On this line?
Yeah, that's where it lives. But you're putting the label next to it.
Because it has to be
Negative
separated
one,
from 0
I.
Right, by one
Zero
unit.
comes
Negative
from
2.
all these rows, so 0 is
Negative
really busy.
Zero is really busy.
Negative 4I.
Okay, I did it.
Yeah.
Someone either kill me or him.
Plus 2i. Where's your 4 plus 2i?
2I.
Let's see here. 4 plus 2i. So are these the pluses? These should be the pluses and these should be the minuses. You labeled them backwards.
Slow mo melted.
Those should be pluses, those should be minuses. One with a plus sign on them.
Every children.
And I think you drew the dots in the right place.
Apple calculator.
I think your dots are in the right place, but your labels need switched. Let me show you.
I did it.
This should be, make that be a plus I. Make that be a plus. Make that be a plus.
No.
Make that be a plus. Make these be minus.
Your grandparents, huh?
Negative. Negative. Right. And it's because they go up and down. You try to have the positive stay up and the negative stay down. Even though, if you looked at it like this, this was the left, this is the right,
over
so usually
again.
the negative is on the left, right?
Is this right?
So then you have 2, let me check it, you have 4 plus 2i, you had negative 2 plus 3i, and then what was your answer?
Which one? This?
Yeah, what was,
This goes 1, 2,
I can't even get it.
no.
and this goes 1, 2,
God bless you.
That's not right, so it's not in the middle.
No, it's not in the middle, necessarily. Add the real parts. What is 4 plus a negative 2?
Do you agree with this guy or with this guy?
2,
So it should be over 2. The real part should be
Do you want to
over
rule
2.
the world or agree that it's
And then add the imaginary parts, Aiden. What is 2i plus 3i? What should that be?
Do you draw an arrow to there
Ooh, it's an
too?
apple.
Yep.
I did.
And I want you to notice something. If you start at z
Yeah.
and then draw the vector a. So
What's a
a,
vector?
a vector is an arrow, a line with an arrow. Did you do your lines with your arrows yet?
Yeah,
No.
yeah.
No, I can't figure out
And then you draw.
So let me catch up.
a
Wait. Let me catch up with all of you guys. So
Wait, how do you combine?
No tree
I'm going
plus
to-
four plus
Numbers.
2i has 4 coming.
that's what we're going to do right now.
Did you not just see what we were doing?
No, I was still trying to finish my number line.
You
That's
add
okay.
the real and then you add the imaginary.
Or
So it'd be
you
6
just attach one vector on the end of the line like that.
Exactly. We're going to be attaching our vectors on top of each other.
But it's
Resultant
bitty bitty blah.
You have it. And physicists are all about that, let me tell you.
We're up to see the wizard, the wonderful wizard of Oz.
Okay, so I'm going to put some of my numbers on here. Let's plot this together. How do I find where A lives? I want to go to A's house and
He lives, his house address is A.
It's 4
One,
plus
one.
2i.
it's 4
Plus 2i.
plus 2i and you put that
Oh, that makes sense. That's what I
and you
thought.
put an A.
Got it.
Okay?
Yeah.
Now, I also asked you to make that into a vector. So the way we make that into a vector is we start at 0 and we say, well, we could go over 4 and up 2, or we could just go like that.
Oh, cool vectors.
Vectors.
Awesome.
Just go straight. Vector is like the straight from here to there path with an arrow Z, showing which way you went. That you didn't go from A to 0, but you went from 0 to A. Yeah, the direction is important. Okay. Now we want to go to Z's house. So which way do I go to get to Z's house?
-2
Negative
plus 3i.
Plus 3i.
We're getting
Here it
this
is.
Yeah.
It has a Z by it.
And then we want to go to
I made a
And we can
triangle.
write, wait, and we can write a vector from
And then
0,
And then we make a triangle?
No, we don't.
almost. Now let's figure out what A plus Z is. So first of all, let's think about what it is. We want to add the
4
real
plus
parts
negative
together.
2
So
is
4
2.
plus negative 2,
2.
2.
2, yay.
2.
Plus
2.
5
imaginary parts plus other imaginary parts, 5i. So let's figure out where that lives.
2.
Yeah.
Oh, do we need to do the Lego symbol for this one or just do
right
that?
between you, can I make VI?
You know what? If you start making fees all over the place, you're going to get confused and get behind. Do you actually even have your vectors drawn?
I like that.
Draw this. 4 plus 2i. You should have a dot and an A by it.
And an arrow to it.
This way?
And an
This
arrow.
one.
Actually, I want to have some help.
Words that go.
Can I get the two of you to
Me?
go over there
Me?
and help younger members of our crowd
Me?
catch
I'm
up?
not young.
Anybody
You
who's...
don't make a triangle out.
There you go. So
Why
help...
don't we make a triangle?
There you go.
What?
Why don't we make a triangle?
So help him catch up
Because
so that he's
then
with
you're not
us.
gonna get any point. So
Can I get you to help
you found
Aiden?
this one, right? Okay, good.
Aiden, he's going to come help you.
Who?
Wait, what do we do?
Oh, actually, never mind.
He's got that.
He's on it.
Yeah.
But you've got yours on your paper, right?
Yeah. You know who
And
Yes.
Josh, do you have your vectors on your paper?
You put a dot right
Not
there
yet.
and mark it with an A. Right
John,
next to
help him. He's not younger, that's okay. Help him anyway.
Yeah.
I think he was having fun drawing an eye of Horus, I think.
What is the deal with the
Everyone likes
orange
your-
eyes?
or something like that.
It's
Anyway,
And then.
Get caught up. Everybody needs to have
Plus,
an
if you know the story, Sid cut out his eye, and that's
And
that's why he got
arrows
it.
on the
One
paper.
God had given him the.
I know, he got both of those torn out. I've read it. I love
No, not both of it. It's
Yes,
only
it
one.
is. Yeah, okay.
It's only one. That's why it's the eye of course, not the eyes of course.
So now draw a line with
There you go.
Cherry
I think the numbers hurt me. Now my head hurts. No, really, it actually does hurt. Or maybe that was from
All their
Euler.
houses.
Maybe that was from the philosophy question if you answered.
You know the hardest question in the world?
So,
What is the
go
answer to all
over.
of
So
Bloom's
what's the
problems?
first clue?
Do you know what the answer
There is
is?
no answer to that.
Yes, there
What
is.
is A?
47.
What?
It's 47. I played this possible quiz game and that was the answer, 47.
I think it's 42.
No, 4 plus 2.
What? That's an unsolvable answer unless you think about that.
I
don't know about
There's a book about this.
There is?
That book's insane.
Hitchhiker's Guide to the Galaxy.
The answer to life,
The universe and
everything is
42.
42.
Yes.
Wait, so it's only one page long?
What's that?
And it just has this giant like 42 on the cover. I can make that look. I can make a look. The answer to the Guardians of the Galaxy problem. 36. This is my controller to
Right?
So,
Magnitude, we're gonna
do
talk about
9
that.
divided by
That's
9.
important stuff. That's right.
Answer!
Wait, we have to add
Good
these numbers
robot.
and have to plot A plus
This
C.
isn't gonna work.
So now,
3?
now that we have,
9. Well, that's the answer.
make sure you also plot the location of A plus Z, which is 2 plus 5i. So how do we get there? Go over 2, plus 5i, put the dot,
Yay.
and write A plus Z.
A plus Z equals 3.
Well, no, it equals 2 plus 5i,
Aw.
but
And then.
Yeah, wait, do we have to draw these?
yeah, let's draw, well,
Oh yeah.
vector.
Oh, now I remember that's the guy from Despicable Me. I just now made that connection.
I think this is going to look better on your paper because you have graph paper than on mine because I
You
have
say
board and I wasn't very careful.
But I had no idea what he's.
However,
And I didn't really listen. But
here's what I want you to do.
Yep.
Suppose you
Oh,
went
thank
to A's house,
Okay.
and then you blew
Okay.
it up.
and A said, "Hey,
You want to blow up my house? You're gonna have to go to the house.
I need to get to A plus Z's house. How do I get from A to A plus Z's house? How do I
Go
travel
boom.
from here?" Now let me draw this a little more accurately. So it's like actually,
I think I know. I think I know
Here.
the answer. I think I know.
how do I need to go? First of all, let's talk about left and right. Do I have to go left or right to get to A plus Z's house? Right. And how far? How far?
2 spaces.
2 spaces. And then how far do I have to go up or down?
Oh.
How far?
Wait.
3.
3, yeah.
3i.
3i. So
Negative 2 plus 3.
notice that is z, right?
Mm-hmm.
So if you put a vector
Plus.
from here to there, it will be parallel to the z vector.
Yeah.
Actually, it's equal to the z vector because this is the other beautiful thing about vectors. Even though they're defined as from 0 to the place, you can then move them around. And as long as they point the same direction and have the same length, they're equal. So this vector and this vector are equal because they both tell you to go the same direction for the same amount of time, same length. So
fall off.
that's that. Now what if you were at Z's house? What if you were at Z's house and you said, okay, how do I get to A plus Z's house from
Add
here?
You
A.
do the same thing.
Yeah.
Go A.
At A.
Go
So I have
A.
to go 4. 1, 2, 3, 4. And then I would have to go up 2. I would still, and this, my picture is really bad, but yours should look, if you draw those, it should look like a really nice parallelogram.
Hang
Is
on.
it a perfect parallelogram?
It should be a perfect parallelogram because those are going to be parallel lines.
Seriously?
Oh yeah.
I thought it was just
So try.
square.
So draw from A to A plus Z,
square.
and then draw from
Parallelogram.
Z to A
It
plus Z.
is a rectangle.
Mine
It's a
was
square. It's a parallel. No,
Not
it's not a
exactly.
square.
It's a square.
I draw.
No, it's a rectangle.
Is
Is
it
that
a
a
rectangle?
right drawing it poorly?
it's a parallelogram.
It's a parallelogram.
Yeah, I think it's parallelogram.
Well, if you look at it like that.
That's what all the sides of
Oh
parallel.
yeah, it is.
That's what all sides of parallel, right?
So you should have, so here's the thing, the meaning geometrically of adding complex numbers is taking the two vectors that define them, making the parallelogram out of them, and then saying, oh, I'll take the shortcut, like across the diagonal. Yes, Asian.
A plus C, driving all over the place, then finally you're gonna land on there at some point.
That is so true, you could take the tour.
Take the scenic route.
But then the people would be like, yo, you could have just gone this way.
And you'd be like,
So much shorter.
oh, now I know. Now
Yeah.
Let's do that next time.
Yeah, Aiden.
I'll find parallel with it.
Did you draw your parallelogram on your paper?
There's something in my hand.
Let's see here. Oh, your lines have to be very straight to find your parallelogram.
Whoa.
My lines aren't very straight.
And also, you had 2 plus 5 eyes.
Gotta
1,
really-
2, 1, 2, 3, 4, 5. This is where A plus B lives,
square.
up here. And
That
it's
looks ugly.
from here to there. There we go.
Would you rather move in
This
raw
will be
or
parallelogram if we're careful.
Let's see.
I don't know.
You two.
Answer.
Oh,
Answer.
actually Z is in the wrong
Who
spot.
would I find? Apophis versus raw.
It'd still be raw, because you needed to go -2.
What about apophis versus
No, it's like a very nice parallelogram.
second? Second. Like the sort of weird lady.
Okay. Yeah.
She's a lion.
Oh,
I'm trying to figure out this, but what is I squared? And
I squared, can anyone tell me what is I squared?
I squared equals negative
Something.
1.
Why?
Because
Oh,
it's
yeah.
square root of negative.
Because I is defined to be the square root of -1, and what the square root means is, hey, when you
Square root?
square that number, you get this thing over here, right?
Isn't this kind of hard?
In fact, the square root means, hey, what number do I have to square to get the thing underneath here? That's what square root means. So this is, I squared is -1. Yeah.
Wow.
I think you lost that thought. Is he coming back?
Oh yeah, why don't they just put this on calculators? Wouldn't that just be easier?
Some of them have eyes. I
Yeah,
think-
it has to be a pretty dang good calculator.
Yeah, I mean, I have a graphing calculator that has eyes on it.
Cool.
Sure.
Googly eyes?
I think you can stick googly eyes on any calculator.
All right, that's
pretty
funny.
similar.
That's kind of funny.
So we're gonna try this again. We're gonna try this. Wait, we're gonna try this again. And actually, I think we need to move people. So I would like.
Why don't you do?
We need to move people because we have certain people who need some more assistance from people who are more experienced. So I would like
He's awesome, so you don't move.
Shlomo and Shlomo, I want you to swap places with Aiden, please.
Now my awesomeness is being
Swap.
tiny because the awesome.
Actually, he's gonna help you.
me?
Yeah.
I'm sorry.
No. Well, you can help Shlomo. That's Shlomo. You're gonna help him. Aiden, you're sitting here.
Everything is awesome.
That song is so
Okay.
annoying.
That's all.
What's
And I want you
that?
to scoot closer to each other.
tight.
I'll be kind
Sit there.
Yeah.
Okay.
Sit there.
My name is Mr. Bowtie.
Sit there.
I'm very serious in my way.
Sit there.
I'm
Okay.
a bowtie.
Reza,
I'm a bowtie.
And Aiden. focus.
And I
Fo-
created the perfect bowtie.
Focus. For a second. It's good that you're curious, but hold that down for a second because we got to learn something. Okay, you ready?
You especially.
Josh and yes, Joseph and Aiden, you three are going to work together. Shlomo and Reza are going to work together. John and Asian are going to work together.
Who's John?
Actually, I think you guys should tell each other your names one more time. Say your name out loud.
Reza.
Shlomo.
Say your name for us.
Agent.
Agent. Okay.
If you can't figure it out, just say whatever.
Hey, whatever.
Agent is his name. John.
Okay.
Go ahead.
Joseph.
Baptist
We're
Joseph.
gonna go with Joshua.
Coat.
I don't care.
You don't care. Just don't call you late for dinner. Okay, your turn. Aiden, Juden,
Aiden, Judah,
Judah,
Ooh, you
Novik.
can also call me Deadpool.
What is that?
All right.
No, Deadpool.
Here's the next problem. I want all of you to do this one. You're gonna need to make a clean piece of paper, a clean graph.
Oh,
I want you
I
to
need
graph
a clean piece of
these.
paper.
Flip it over.
Agent asked us to do omega.
Yay, Omega!
So omega is gonna be equal to
Also known as an upside down horse.
-5 plus a -4i.
Oh, why is it have to be I? Why can't it just be negative?
Actually, that'll be the next one. And then, just for the fun of it, let's see, let's have another letter.
Alpha.
Oh, you like alpha?
Yeah, alpha.
No, alpha's over.
Actually, do we want, well, if you do lowercase omega, it looks like this, right? Okay, so we'll do lowercase alpha. Alpha, is that, so actually, let's just do straight up, -4.
Yay.
And then I want you to find, I want you to graph these, put their vectors, then do omega plus alpha.
Wait, alpha is just negative
also,
4.
and I'm
I have a question.
Yeah.
You're
not allowed to have a
question.
Yes,
Why don't you do
Not bad.
-4i plus -5? It's the same, but you just continue doing it like that.
it is. That's a really good question, Agent. So, you could do it either way. You could always put your imaginary numbers first if you preferred it. When you're a mathematician and you're doing lots of calculations, you get in the habit of keeping things in the same order so you don't confuse yourself. So I've gotten in the habit of putting the real parts first and then the imaginary parts, and most people do it that way. Sometimes people like to put the i's in front of the second part, so it would be I parentheses -4. Sometimes they put it like -4i. It does, but you're right, it doesn't make any difference.
I found out.
You need a new piece of graph paper. Did you know that? And you need to do this.
I can't see it. Where is it?
Focus.
Graph. There it is.
So grab a piece of, can you guys hand him a graph paper? He needs a blank one.
Catch.
Thank you very much, John. Peel one off.
John.
You need to put omega and alpha, and then omega plus alpha, and then we can have other conversations.
I had to do that.
You gotta get caught up.
What did I
John Adams.
Yours.
John will
Start here.
Guys,
Plot omega. First make your graph. Plot omega. Plot alpha. Plot omega plus alpha. Josh, do you have a new graph paper on your? There you go. Draw it. Let's go.
You don't need to make a marker if you can
Chuck Norris for knows where you live, but you don't know Chuck.
So first make your little graph, then I want you to plot omega, plot alpha, plot omega plus alpha.
Get on social networks.
That helps your partner.
Not really. Except multiplayer games.
Reza.
Oh, plus.
Look up where does
Yeah.
Chuck Norris live.
Agent, do you have omega drawn? Plotted.
No.
Okay, make a new plot, new paper.
That's what I'm doing.
Okay. Okay.
Do we have to have a new graph?
You do need a new plot.
Yeah, it's probably a really good idea.
Yeah, so you don't get confused with the old plot.
Oh yeah, now I figured it out. I need to
Okay. And then down here, make your graph.
I confused it. I
Are you
confused
sure
it.
that's that one?
Confusing. What is it? The
That's
accent.
that
Confusing.
one. Like, I mean, are you sure that's that
I
one?
have a philosophy.
Right?
That's really
Make a
hard
new
to
graph.
Yes, make a
What's
little
his name?
plot.
Oh, Jack.
Chucky Shake. Chucky Shake.
You're not. I don't go on much social networking sites. I know that's movies though. It's like from
Agent, are you distracting John?
Rentals, what are you talking?
Wait, rental? What's that?
You just talking about renting movies.
Oh. No, I'm saying those movies. Like Rush Hour 1, Rush Hour 2, Rush Hour 3.
I have no idea what you're talking about.
I know you didn't.
Draw.
Draw?
Yes,
Draw what?
label. Label your label
Oh,
your
wait. I have never.
your reals and your imaginaries.
Okay, got that thingamajiggy.
It's not Greek weirdness.
Well, yeah, I mean, there's Aristotle and
Okay,
stuff.
that's not gonna work.
Aristotle.
What's it? We're almost not working. Oh yeah, here we go. Fix.
You were writing too big.
Break. Fix. Break.
So when we write the number 1, it stands for this mark. When we write the number 2, it stands for this mark. 3 stands for this mark. 4 stands for this mark. The numbers stand for the marks. Negative 1 is here. Negative 2 has to be here. Negative 3 has to be here. So negative 3 is getting farther away. Negative 4 has to be here.
Is that right?
No, you're completely wrong.
So you need bigger graph paper.
Negative
Because
4
your
is right
handwriting
here.
is bigger. So let's try this.
IJKLMP. QP.
No.
What QP?
QP. So right by the line, write a 1.
What QP?
Or at 1 eye. Right by the blue line, 1 eye.
Oh my gosh.
Put 1 eye right by that mark.
Okay, is that, I don't know. That one's actually.
BC.
Or
That
2
looks
eye
like
goes
when
here.
this person is dying, they have a little heartbeat.
And they're putting
Chicken.
What is that, a negative 5?
No, it's a positive 5.
That's a negative 5.
No, it's a
Should be the
negative
eye.
4.
It's negative 5, see?
Negative 2.
No, this is eye.
Drawing me a purpose.
I'm just giving you the opposite answer would best.
This is 2.
It's a negative 5. 5.
That's where 2 eye lives.
Hi.
And then 3 eye lives over here. So get another mark. No, don't be silly.
Safe. Un-TNT.
TNT alarm.
Keep going.
No, safe non-TNT.
You guys are weird.
4.
Okay. Now, Josh, do you have your omega and your alpha on your plot? Yet? Oh, you're still
Say
numbering.
omega.
That's okay.
Alpha, omega.
Yeah, your alpha and your omega.
Okay,
I
I replotted.
On there.
Because I needed to. I meant replotted the thingies, not.
Why? What
You're
thingies? What
you still need to
thingies
write
are
the
you
bigger and
talking
bigger and
about?
bigger.
What
That would be
thingies?
the front one.
Alright, nice curve.
Right. So,
Yeah, good boy. 2
oh,
eye.
yeah, see, you're really
2 eye.
3 eye.
I am 3 eye.
Bye-bye.
Someone just killed
negative
me.
1, negative 2 eye, negative 3 eye.
But you
Yeah,
haven't
yeah,
lived
one of
on
those
to a
seven.
horrible
Right.
principle.
Right, too big. You're writing too
No,
big.
it's worse.
How are you gonna fit
The world's worth
by
it.
this mark? You're writing so big, it's not gonna fit.
You might want to.
Take it easy there.
Whoa!
negative 5 plus
Extreme action going on over here.
Yes.
Dude.
Okay. Now you're ready for your reels.
It's gonna be that
And they have to fit here. So this needs to be the 1, 2, 3. Those numbers. You're not too big, or you're gonna get in trouble.
You're good.
It looks like the double.
You're good.
Little black house in Nugent's.
I'm around on the karate.
So,
Alright, anyway.
So you will have the blue belt.
so
Don't forget your negatives.
How high do you take
How
karate? How high do you
Okay, negative 1.
Depends. That's why karate does
Where's
nothing.
alpha?
negative 4.
Do I put them together?
No.
I'm confused with the.
No.
Dude, that's Indian.
No, that's
No,
Chinese.
that's not.
No, it is.
No, I wasn't in the commercial. Yes, they do. They go.
Okay, let me see. How many people have omega plotted?
I have Omega, but not the other one. The other one's.
Ah, it might help to say, well, what is the imaginary part here?
Ooh,
Just
0.
the
0 eye.
0 I. So you could put in your mind, you could fill that
Okay,
in.
I got the number.
So that's I?
But I can't do it without curving my vector, which is annoying.
It's gonna be a
What's a
straight, it's gonna be on the real line.
What's W?
Yeah, I told
Oh,
you
it
that.
is?
Yes.
What's W mean?
It's that. I told you. It's
Omega. It's an omega, it's not a double. Not equal.
That's not the way they.
My fingers are great now. Or different color right there.
Like, there it is.
2. And then
Oh.
this one.
Okay, that makes sense.
A plus B.
Okay, are you finished?
Yeah!
So now,
To
plot, okay.
omega.
Oh, okay.
So
no idea what it is.
Negative 1.
Okay.
I don't know what that is.
This would be now.
Okay,
Now.
so omega. This one.
Yeah, Omega
This is
means
actually
last.
So
supposed
let's
to
see,
be like
where is
this.
your omega gonna go? Omega is -5
And then draw
plus
the arrow.
negative 4i. So let's do it. Negative
That's
5.
omega. Now,
Fingerprint.
so you want, where is
No,
it?
no, negative
What
5.
does it say? 5 plus 4i, right?
There you go. Plus
Negative
negative
5.
4i.
That's Minecraft,
Wait,
right?
this is negative
It's
5i.
not
Don't put it
supposed to
out
be
yet.
negative.
Now go negative
What
5.
happened to my
Now.
Minecraft?
It is supposed to be negative 4i. Never mind, I
Wait, what
didn't-
happens in
I'll have to
Minecraft?
start over.
Wait, what
Oh.
happens in Minecraft? You go into space and explode.
Hey, I know what that
No, you
is.
didn't
That's the
mod
sand temple where there's sand zombies that weird blocks of
Right.
sand.
That's right.
Wait, can you go into space
Yeah,
and
you can
explode
get a
in
mod
Minecraft?
where
Put a
pretty
mega
much a
mod.
sand temple turns into a giant sandcastle.
No,
Mod is
no, it's an omega.
Oh, yeah.
No, it's Greek.
I have a mod.
You
You
can
can
do
ride
negative
it.
4.
Scorpion.
Plus 0i. So you're right here.
I can punch you 5 times.
I don't want
Do
these.
that,
So
and
not,
you'll find your face in the wall.
not right on.
So 10 times.
And now alpha.
Do that, and you'll find your whole body in the ground, buried, and you'll find me moving your head around with my
Watch.
hands like,
Watch.
dude, I don't want to have to. Hey, don't forget, I have pizza ninja stars, and I'll throw them at you, and there's no way you can eat them in midair.
Delicious.
Oh,
Now we have to add
It's like you do a 360, you
No, no, no.
take
I'll
a
just
chomp out of it.
go Matrix style.
Wait,
I'll
that
just go
dot is
Matrix
too big.
style.
The dot should be right on the line matrix. That dot is crazy.
I don't need that.
Put a line.
So it's negative 4.
Ready, ready?
Then
Put a line from here. So it's
Wait, this is what this is all like
No, no, that's right.
That's
That's
correct.
That's almost like a penalty. Yes, but it needs to be a straight
So it's same thing.
I did
as
two.
I being the square of negative 1.
Really, yeah. And then I've also done like
straight.
Okay, that's better.
with my heel. This
Omega.
You thought omega.
That's the show we got in sprinter, so you know my battle.
So now we draw.
All right. Now,
Guess what?
if this came out for you guys, it should look something like this.
Whoa, yeah, I have that. It's all
I don't have it.
right.
I don't have it. I don't
And you
Yeah.
should have a vector that looks like this for omega.
Omega?
Wait, hold on,
There?
I'm not finished.
Oh.
Your alpha should be over here, right on the real line.
Or 3.
Oh, wait, did I put my numbers wrong?
And then the vector for that looks like this.
I think I did I reverse my
7.
And then, when we do the parallelogram,
Yeah,
it should
but
look
it's
like
fine.
this.
Just
This
leave it.
is where omega plus
You
alpha
made it
Everybody's
right.
seen the line.
It's supposed to look like this.
and the vector.
Hey, I got 2
Yeah,
pizza
that's fine.
slices.
So it would look,
Let me guess.
it would look like this.
I have a question.
So, save your question, we're about to be done. I want to challenge you guys to something.
Challenge it.
No, don't challenge. No challenge. No challenge.
The question,
No challenge.
the question is, if you had a number, like, 2 plus 3i, and you multiplied it by I,
Uh-oh.
what
That's
would it
challenging.
do?
It is.
Well, where would the answer live?
It would live in a house.
Write this down in your notes.
Okay,
If you have 2
I don't
plus
have
3i,
notes. Josh, can I steal your notebook?
well,
paper?
just grab a piece of paper,
Yay.
take that
I
home.
have a question.
Just put it on your paper.
Last week. Go
John, just write on your paper.
Oh.
So write down, the question for the week
I didn't
is,
get it.
if you have 2 plus 3i and you were to multiply it by I,
I'm just writing this huge.
what would you get?
What's negative 5 plus negative 4?
If you figure that one out and you want a little bit of a more general challenge, the question is, in general, suppose I had negative 2 minus 5i and I multiplied that by I, where would that go? What does multiplying by I do to complex
I already
numbers? That
got
is
one
my
of them
question.
done already.
What does multiplying by I do to complex numbers?